So last time we were doing surface areas, right? Surface areas of cylinders and this and that. Let's see what the next part has for us. So again, just to quickly review, so you have this as a cylinder, you have two circles, one at the top, one at the bottom, yeah? So the surface area for the area, you want to find the areas of this, this, and this. It's a three-part problem. So the area for the top is pi r squared. The area for the bottom is also pi r squared. So when you add them up, you get 2 pi r squared plus, now for the central part, we're going to cut it apart and make it into a rectangle. So the height is going to be h, and the length of this is going to be the circumference of the circle, right? So 2 pi r. So the first formula is 2 pi r times h. That is for the surface area. For the volume, very similar. Volume is always the base area times the height. Now at the base area, this is a circle, so that is pi r squared, and the height of a cylinder is going to be given, that is h. Yeah? So surface area volume of a cylinder, pretty straightforward. Let's see if it gets a little bit trickier. I'm sure it does. Does this have anything to do with cylinders? I guess we'll find out. Nope, this has nothing to do with cylinders. So it's going to be something a little bit different than yesterday. Maria and Tran are playing a game with 2 standard dice. You know what that is, right? Like it has like 1 dot, 2 dots, up to 6 dots. So every dice has 6 faces. Okay, it's a cube.
Yep.
To win the game, they need to roll a sum of 8. What is the probability they roll a sum of 8? Let's take a step back here. Let's talk about probability. Okay. Let's talk about a coin. Dice has 6 sides. A coin has 2 sides, right? There's going to be a head, and then on the other side, there's a tail, yeah? So if you flip a coin once, what's the probability you roll a head? Probability means the chance. So there are 2 possible outcomes, yeah? Either you roll a head or a tail. So the question is asking you, what's the probability or what's the chance that you roll a head? It is 50% or a half.
Okay.
Okay. Now what if we say this? Suppose you roll a coin twice, okay? Yeah, you flip a coin twice. What's the probability that you get heads both times? Now that one's a little bit more complicated. So for that, we have to understand something called a tree diagram. Okay, it's pretty simple once you want to get a hold of it. So here's the first coin, yeah? We flip it. What are the possible outcomes from the first coin? You either get a head or you get a tail, right? Now we're going to flip a second coin after this. So the second coin, either you rolled a head on the first one, yeah? Then from this one, either you roll a head or a tail, or let's say you rolled a tail on the first one, and from that again, you roll a head or a tail, like that. Okay. And so what are the possible outcomes when you roll a coin twice? You either get a head and a head, yeah? Or you get a head and you get a tail, and then you get a tail and then you get a head, or you get a tail and then you get a tail, like that. Cool. So how many total possible outcomes are there when you roll a coin twice?
4.
4, right? And the question is, what is the possibility or the probability you get 2 heads? So that's only happens once, right? So the answer is 1/4. So the probability you roll a double head is 25% or 1/4.
Okay.
That makes sense? So this is called a tree diagram. Okay. What if we spice things up a little bit? Same diagram. What is the probability when you roll when you flip a coin twice that you get at least 1 head? So again, the total outcomes are 4, right? At least 1 head means, yeah?
3.
Yeah, exactly. 3/4. What is that as a percent?
Like 75.
Yeah, exactly. So the probability that you get at least one head in a double coin toss is 75%. Good?
Yep.
Now we're gonna do this dice problem. It's fun. Probability is fun. You can use it in real life as well. So what I'm gonna do is I'm gonna make a column and a row, okay? Like that. So when you roll a dice, what are the possible things you can get? You either get a 1, 2, 3, 4, 5, 6, right? On the first dice, or you get a 1, 2, 3, 4, 5, 6 on the second dice, yeah? So either you get a 1 on the first, a 1 on the second, a 1 on the first, and a 2 on the second, like that, right? You get a, what does this mean? This means you roll a 1 on the first dice and you roll a 4 on the second one. And then you go like this, okay? So what's the entry here?
2 and 1.
Exactly, 2 on 1, and you keep going like that. And then the final entry here will be 6 and a 6. Okay? Well, to save time, I can make that, but I'm just gonna copy paste it from Google. So when you build it up, it's gonna look like this. Maybe this one. This one's even. Which one would be better? So here, let me show you what's going on here. I think this one's the perfect one for this one. So this, they've added the values already for us, okay? You see 1 and 1, you get a 1 on the first, 1 on the second, the total you get is a 2. Why are we finding the totals? Because it says, what's the probability of rolling a sum of 8, yeah? So how many outcomes are there in total? So we can find the area of this squared, okay? The length on top is 6 units, yeah? And the width is also 1, 2, 3, 4, 5, 6 units. So what's the area of the square?
36.
36, right? So that means there are 36 possible outcomes. The next part, how many 8s did we land? How many 8s can we get?
5.
5. So there we go. That's the answer. 36 total outcomes, and we get an 8. There's 5 instances that we can get an 8. So the answer is 5/36. What if I asked you, what is the probability of rolling a sum greater than 8? Greater than 8.
$15.
Greater than 8, yeah? So 8 is not inclusive. So you can either get a 9, yeah? So you get a 9 4 times. Then you get a 10 3 times.
Okay.
So 4 plus 3, and we know the total is 36, right? Then you can get an 11 twice, and then you can get a 12 once. So 4 plus 3 plus 2 plus 1 is 10. So 10/36, and you can reduce that to 5/18. Okay?
Yeah.
The probability of rolling a sum greater than 8 is 5/18, like that. What is the probability of rolling a sum of 2?
Just once.
Yeah, so 1/36. Okay? So that's a probability question. Yeah, I don't know why that was there. It's pretty random. But it doesn't hurt though. Oh, this one's gonna be fun. Now this one's basically gonna use everything we've learned in this unit and the unit in the last unit. It says calculate the total volume and surface area of the whole cabin. So how would we do this one? Let's first find the volume. It's easier. Okay. Let's first find the volume. So what is this cabin made out of? So it's made out of like a cube on the bottom, yeah?
Mhm.
And then it's made out of a triangle on the top, right?
Uh-huh.
It's actually called, it's not a cube. Cube is when all three sides are the same. This is called like a rectangular prism. That's the technical term for this. And the top part is called like a triangular prism. Okay.
Okay.
So I'm just gonna call that rectangle and triangle. So we have the volume of the rectangle plus then you have the volume of the triangle, yeah?
Mhm.
What is the volume of this rectangle? We're cutting this graph right there. What is the volume of this part? There's a formula for it. It is the volume of anything is the base area times the height. Yeah?
Mhm.
The base area times the height. Yeah, so what's the base area here? It's length times width, yeah? Rectangle.
Uh-huh.
So the volume of a rectangle is just LWH, length times width times height, because this is the base area, length times width.
Okay.
So we have 1.8 times 2 times 2.2, right? Plus, now what is the volume of the triangle?
Um. Just length times width times height.
So it's not going to be because if it was length times width times height, we would get the area of this entire thing. You see that? Like that?
Oh, okay. Mhm.
So it is not quite that. It's close, but it's not quite that. We have to make a little adjustment. What if we do this? Instead of doing it, instead of looking at this as the base area, yeah, which we did for the bottom problem, right?
Mhm.
How about we look at this as the base area? This part. This face, we're going to use that as the base area, okay? And then the height
Okay.
would be 2, because if that's 2, then that's going to be 2. So we're going to use this as the base area. So what is the area of this triangle here?
Um.
So the area of a triangle is base times height over 2, yeah? So the height is 0.5, yeah?
Mhm.
What is the base of this triangle here?
1.8.
Yeah, exactly. So you have 1.8 times height, right? 0.5. So this is the base area. And then we're going to multiply this by the area of this, the height of this roof. Okay.
Okay.
The base area is 1.8 times 0.5 over 2, because that's the area of the triangle. Then the height here will be 2, like that, times 2. And that is going to
Okay.
be the volume of the total thing. Alrighty.
Mhm.
So let's plug that on the calculator. 1.8 times 2 times 2.2 plus 0.9 times 0.5 times 2. And I get the volume of this guy as 8.82. Now, what is the unit?
Um. Meters.
There is a meters, yeah, but it's not, meters is not a unit for volume. Not just meters.
Oh, cubed.
Yeah, meters cubed. So that is the volume for the entire thing.
Okay.
All right.
Mhm.
Now let's work on finding the surface area. So again, we're gonna have to break this down. So it's gonna have 2 of these, yeah. It's gonna have 2 of these, right?
Mhm.
So 1, 2, 3, 4. What about the bottom? Are we counting the bottom?
Yes.
All right, let's count the bottom. So we have 5 sides for the rectangle. Okay.
Mhm.
So we know there's 2 of this for front and back, and then we know there's 2 of this for front, side and side, and then there's 1 at the bottom. So let's first find this. What is the area of this rectangle? The front face.
1.8 times 2.2.
Yeah, good. So 1.8 times 2.2. So this is a front face, but there's two of them, right? There's one at the back, one at the front. So we're done with this side and the back side. Now let's go side to side. What is the area of this face?
2 times 2.2.
Yes. And again, there is two of them, right? There's one here, there's one on the other side. And what about on the bottom?
It's 1.8 times 2.
Yeah, but there's only one of them, right? Because the top, we don't have that part at the top. So that is for the rectangle. And now we're done with that. Let's work with the top part now. Now what's going on the top part? You have this triangle, and then you have the exact same thing as the back as well, right? At the back. So what is the area of this triangle? We have that up here, yeah? Base times height over 2. So base is 1.8, height is 0.5 over 2, and then there's two of them. What else do we need?
Like the top part.
Yeah. So now what is this shape?
A rectangle.
So if that is 2, right? What is this gonna be?
It's also going to be 2.
Yeah. What about the height? Oh, what about this side? Sorry, this side. Now notice for that side, it's not given. We're gonna have to find that. To find that side, we're gonna have to use the Pythagoras theorem. You see, they've given us a right angle here for a reason.
Oh, okay.
So this is 0.5, right?
Mm-hmm.
And the total is 1.8. So what's gonna be half of 1.8? 0.9, right? So up until here is 0.9, the height is 0.5. Now we have A and B, we're looking for C. So what's gonna be the height? Not the height, sorry, what's gonna be the hypotenuse? You're gonna have to use a calculator and use the Pythagoras theorem. We're looking for C.
Is it 1.03?
Yeah, it is. Perfect. Okay, so that's 1.03. So what's the area of this rectangle?
2.07.
Yeah, 2.07, but then there's two of them, right? There's one roof here and then there's one roof on the side. And then we just multiply that by 2. And there we go.
Okay.
Okay, pretty tricky. We had to do every side, every face one by one, but that's just how it is. That's what people do in real life as well. If you go into like architecture or something, you'll be doing this. Not even architecture, like if you are just into building your own cabin, stuff like that, you'll be doing this. It's 2 plus 1.8 times 2 plus 1.8 times 0.5 plus 2.07 times 2. So the surface area for the entire thing is 25.36. Now what is the unit?
Meters squared.
Yeah, perfect. There we go. And you're done. Okay. So this one was a little bit trickier. Let's do another one. So again, volume is easier than surface area. So we're gonna do volume first. So you notice that this is made up of like a rectangle in the middle and two different triangles, yeah? So volume equals to the volume of the rectangle plus, oh, and then these two triangles are not the same because this is 1.6 and this is 2.1. Yeah? So we have the first triangle on the left. I'm just gonna call that PL triangle on the left, and then you have the triangle on the right. Alrighty. What is the volume of the rectangle?
Base times height.
So we're looking for the area volume of this guy, right, in the middle. It's a base area times height. So what is the base area? So you see this is 1.2, then inside here is 1.2 as well, yeah? So the base area is 4.2 times 1.2. Do you see it? 4.2. So the base area for the rectangle is 4.2 times 1.2. What is the height of the rectangle?
1.6.
Yeah, there we go. Rectangle volume done. Let's look at the left triangle. So this triangle, yeah. What is the height of this triangle?
It's also 1.6.
Yeah, it's also 1.6. Now what do we do? What is this side length? See, that side length is the same thing as here. So it's this one right here.
Oh, okay.
So you see this side is 1.2. That side is also 1.2, okay?
Okay.
So what we're gonna do is we're gonna treat that 1.2 as the height of this triangle. And we're gonna find the base area using these two. Cool?
Okay.
So what is the base area of this triangle? Which is the area of this face, basically. Area of a triangle is base, yeah, base 1.6 times height, which is also 1.6, divided by 2. Yeah? So that is the area of this. And then what's the height of this? We're going to take that as the height. That is 1.2, like that.
Okay.
Base area times height for this, okay? Now you're going to tell me for this one. What is the base area? Which is the face, this face?
1.6 times 2.1
Yeah?
over 2.
Yes, good. Now what is the height of this?
1.2.
Yeah. And there we go. That'll give us the volume. Cool?
Okay.
So we can just find this. Yeah, it's gonna be a little bit tedious to plug in the calculator, but that's just how it is. Plus 0.8 times 1.6 times 1.2 plus 0.6 times 2.1 times 1.2. So the volume of the whole thing, again, it's meters, so it's gonna be meters cubed. 11.112 meter cubed.
Okay.
Does this make sense?
Mm-hmm.
So for a rectangle, it's easy, okay? For a rectangle, it's just LWH, or the base area, which is gonna be 4.2 times 1.2 times the height. For a rectangle, you wanna find the area of the face, and then you wanna multiply it by, this is gonna be the height. Okay, notice the difference. For a rectangle, this is the height. For a triangle, this is gonna be the height.
Okay.
I guess what you could have done for the triangle is this as well. You could have found the base area, yeah? which would be 2.1 times 1.2, right? Over 2, the base area, the base area. And then what is the height of the triangle? The height of the triangle is 1.6, right? But if you look at a rectangle, this is the volume of a rectangle, yeah? We're just interested in the triangle because this part is missing, right? This part does not exist. So we just want to divide that by a 2. And this is the exact same thing as this.
Okay.
So we're going to use that approach as well. So that is the volumes. Yeah, it's not that bad. It's just a little bit long, but it's not that bad. Let's find the surface area. So again, do we include the thingy on the bottom? I'm not sure if we should include it. Yeah, let's include it. Yeah, that makes sense. Well, we're gonna include it. So let's first find the surface area of this guy, yeah? And it's we're just gonna multiply by that by 2, and then we'll find the top and the bottom of the rectangle, okay?
Okay.
So what is the area of this face?
4.2 times 1.6.
Yes. And we're gonna multiply that by a 2, yeah? What about the top part? What is the area of the top part?
4.2 times 1.2.
Yeah, good. And there's again 2 of them, right? Top and bottom. So we're done with the rectangle. Now let us move on to the triangle, yeah? We know the area of this. We did this before, right? Base times height. We know the height is 1.6. So it's going to be 1.6 times 1.6 divided by 2. Yeah, this is the area of this face. And we know there's 2 of them, right? Going to multiply that by a 2. Okay. And now again, you see there's something in the bottom. How do you find the area of that bottom piece? It's a rectangle on the bottom. So you see that's going to be 1.2 as well, yeah? This is 1.6. This is going to be 1.2.
Okay.
So that's going to be the area on the bottom. 1.6 times 1.2. Now this one's a little bit complicated. What's going to be the area of this face? We already know one side, right? The bottom one, this is going to be 1.2, right? This way. So we need to find this part. How do we find that? You want to use Pythagoras theorem, yeah? So once you try that, we're trying to find this slant height here. We have the 2 sides of the triangle. We can use Pythagoras theorem to find it. Again, we're looking for C. We have A and B.
Okay.
So try to plug it in. What do you get?
It's 6.6.
That sounds too big. You need to square root that. No, it's not saying. What did you do? So we have 1.6 and 1.6, right? We're looking for C. We need to use the Pythagoras theorem. So C is equals to square root of 1.6 squared plus 1.6 squared. Yeah? That should give us not 6. It's going to be 2 point something. 2.26.
Okay.
So now we have that side. We can find this faces area, which is going to be 2.26 times 1.2. Good? Okay, plus now we're going to find this face. What is the area of that face? So this is a triangle, right? Base times height over 2. It's going to be 2.1, yeah?
Mhm.
Times 1.6 over 2, right?
So 1.68.
Yeah, and then there's going to be 2 of them, so we're going to multiply that by a 2.
Okay.
Plus, now let's look at the bottom part that's invisible, yeah? The part on the floor.
Mhm.
What is this length?
1.2
Yeah, exactly, it is 1.2. So it'll be the area of the bottom face. 1.2 times what?
times 2.1.
Yeah, good. Actually, we just need one more thing, and that is this face.
Mhm.
So for this face, we know this is 1.2, right? So that means we're going to need this side length. Again, use Pythagoras theorem. Tell me what you get for this side. A is 1.6, B is 2.1. We're interested in this C.
It's 3.2.
Uh,
3.1.
it is not 3.1, no.
Oh.
Try again. So what are you using as A and B? 1.6 squared plus 2.1 squared, yeah?
Mhm.
So C is going to be 1.6 squared plus 2.1 squared, the square root of that. Once you plug that in your calculator, it's not going to be 3.1.
Um, 2.6.
That's right. That's more like it. So that side is a 2.64, right? So the area of this face is going to be 1.2 times 2.64, and we're done.
Oh.
Okay, pretty tedious,
Mm-hmm.
but it's not that bad. So this will be worth a lot of points. So you can get those points pretty easily. I guess easy is relative. Plus it's very tedious though. Plus 2.1 times 1.6 plus 1.2 times 2.1 plus 1.2 times 2.64. So the answer I got is 39.76. And there we go. Okay,
Mhm.
easy?
Kind of.
Not really easy, but you'll be able to do it, okay?
Mhm.
Let's look at this one. So this guy's making a window. It consists of a rectangle that is 0.5 meters wide. Okay, so this is 0.5 meters, and the length is 2.5 meters long with a semicircle above the rectangle. So something like this, that's what they mean, okay?
Mhm.
Sketch an outline of the window, done. How much glass does he need? So basically the question is, how much glass do we need to complete this window? So what do we find? The volume, the surface area?
The area.
Yeah, exactly. So what is the area of that rectangle?
Um, it's 1.25.
Yeah, so this is 1.25 meters squared. Now on the top, we have a semicircle, right?
Mm-hmm.
What is a semicircle? Semicircle is half of a circle, okay?
Uh-huh.
What is the radius of this circle?
0.5.
Nope. 0.5 is it's not the radius. 0.5 is the what?
Oh, the diameter.
Exactly. So the radius is going to be half as long, yeah?
Mhm.
0.25. Now we know the area of a circle is pi r squared.
Mhm.
A semicircle is half as big, so what do we do with that?
Um,
We divide it by 2.
okay.
Okay, so why don't you
Mhm.
find me that? So r is 0.25, plug that in the calculator, divide by 2. And let me know what you get.
I got 0.09.
Yeah, that's right. Okay.
Mhm.
So the answer is 1.34 meters squared.
Okay.
Now let's look at this. To copy a poster, this person reduces each dimension by 70%. So he reduced the dimensions by 70%. Now what does that mean? Let's say you have 20, okay?
Mhm.
You reduce it by 70%. How much is left? Now how does that work? So how much is left? How much in percentage is left? You have 30% remaining, yeah? So the answer, if it was 20, it's gonna be 30% of 20. That is gonna be 6, okay?
Wait, what?
So if you, let's say you had something that was 20 meters long, okay? And we reduced it by 70%. So how much of the original is left? 30% of the original is left, right? So the answer here
Okay.
is 6. Not for this question. This question will do. But the idea is this. Another one. Let's say you had 50 meters of a rope or something, yeah?
Mhm.
You reduced it by 60%. So how much is left? 40% is remaining, yeah? No, you don't get that? Let's say you have
No.
a rope. Let's say this thing is 50 meters long, okay? And then we reduce it by 60%. That means we cut it, yeah? And then we get rid of this part. So if this is 60%, how much percent is this? How much do you have left? 40, right? Because it should always add up to 100%.
Oh, okay.
So if you have 50 meters, 40% would be remaining, and then you do 40% of 50. And again, percent, you just change that into a decimal. Off just means
Mhm.
a times 50, so the answer is 20 for 50 meters.
Okay.
Okay, now let's look at what's going on here. So this will be an equation though, because, or would it be? Let's see. I don't know why it's not letting me erase with my stupid pen. Anyways, so we have this, okay?
Mhm.
And the width of this is 0.4 meters. And now we've reduced it by 70%. And the question is, what's gonna be the new width? So what is this gonna be? So if you reduce it by 70%, how much is remaining?
30%.
30% exactly. So what's the answer here? It's 30% of 0.4, right?
Mhm.
So what does that give you on a calculator?
How do I do that?
You change the percent into a decimal. So what's 30% as a decimal?
Um.
Just divide it by 100, it's 0.3.
Oh, okay.
And off just means a times or a multiplication. So 0.3 times 0.4.
0.12.
Yeah. Right, you get this? Reducing it. So you're just interested in how much is left.
Okay.
For example, there's a phone on sale for 200 bucks. It's on sale for 60%. What is the
Mhm.
price?
Um. 40%.
Yeah, so how much do you have to pay? If it's 200, 60% discount, how much do you pay?
Um, 0.4 times.
Yeah.
Do I like multiply it by like 200?
Yes, that's exactly what you do. So 60% discount means you're interested, the final price would be 40% of 200, right? Because that's what remaining. 40 is 0.4, off is times 200. So the answer is $80.
Okay.
Now this is the pattern questions. So this is the rubric for it, okay? Tn means on the nth diagram, there are A means the first diagram, how many squares there are, plus n minus 1 times d. This means this is the diagram number, okay? Figure number. And A is the number of squares in the first figure, right?
Okay.
So there's 2 plus n is just n. And now what's the d value here? D is the difference between them.
D is 2.
Yeah. Okay, like that. So we want to find, this is Tn, we want to find T100. So that is going to be 2 plus 100 minus 1 times 2. And what does that give?
Is it 202?
Yeah, that's right. Actually, let me double check that. No, you didn't do 100 minus 1. So it's going to be 2 plus 99 times 2, yeah? 198 plus 2, so that's going to be 200.
Oh, okay.
So what does that mean? That means figure number 100 will have 200 squares. That make sense?
Yep.
Alrighty, so there's a city park and that is a square. Okay, cool. So we have a square and square means all the sides are equal, right? And then each side is 600. All right. So each side is 600. Diane started walking from a point 150 meters south of the northwest corner. So can you point me out in this diagram where that is?
The top corner to the left.
Here, northwest, yeah. So she started walking from here. So this is the northwest corner, yeah. It's 150 meters south of the northwest corner. That means she started walking, yeah, you see from here, let's say she started walking here, and this distance is 150.
Okay.
So what would this distance be? If the entire thing is 600, that's 150, what would this be?
450.
Yeah, good. Okay, that's all the information we have. So let's move on. Straight to a point 150 meters north of the southwest corner. So from this point, yeah, she walked straight to a point 150 meters north of the southwest corner. So what did she land? This is the southwest corner, yeah? So this distance is 150, right? The question's asking you, how far did she walk? She walked 150 meters south from this point to 150 meters north from that point. So what is this distance here?
150 plus 150.
Yeah, good. That is 300. Cool.
Mhm.
Another way you could have done this is, you see, we know up until here it's 450, right? Up until there it's 450. If this is 150, so that means this one's gonna be 450 minus 150, which is 300.
Okay.
All right, so this guy has wants to paint his room. How do we draw his room? So we can draw something like that. So how many faces are there in a room? 4 faces, yeah? Or is there 6 actually? No, there's gonna be 4. You don't usually paint the ceiling and the floor, right? Like you don't paint this top side, yeah? And you also don't paint the floor. So you just paint the 4 sides. So his room is 3.4 meters by 2.6 meters, yeah? That is the length and the width, okay?
Okay.
So this is 3.4 and 2.6 means this is 2.6. And the height is 2.7, so this thing is 2.7. Good?
Yep.
So what is the area of the 4 walls? So we might have to do this one by one. Let's first focus on this one. The front wall, yeah? What is the area of that wall?
9.18.
Yeah, you multiply this with this. So 9.18, and we know there's 2 of them, yeah? One in the front, one in the back. Like that, right? Plus, now what's the area of the side wall?
7.02.
Yeah, that's right. So you have 7.02, and that also you have 2 of them, yeah? So let's add all of them up. So we have 9.18 times 2 plus 7.02 times 2. So the answer is 32.4 meters. What's the unit? We're looking for the area, so it'll be meters what? Area, not volume. Meters squared.
Oh, okay.
That makes sense? This one was not that bad, yeah? But we're not quite done with this problem. It says 1 liter of paint covers about 10 meters squared. So now this is a ratio question, okay? Here, look at this. 1 liter covers 10. Okay, again, you can just do, here's the liters and then here's the area. So 1 liter covers 10. How many liters covers 32.4? What do we have to do to 10 to get 32.4?
Multiply it.
Yeah, by how much?
Just by 32.4?
No, by 3.24. Yeah, if you multiply 10 with 32.4, you get 320.
Oh, okay.
324. So you want to multiply 10 by 3.24, right? Whatever you do on this side, we also do the same thing on the other side. So you multiply 1 by 3.24. So X, or the amount of paint required, is 3.24 liters.
Okay.
5:7 is to X is to 35. Find me X. So again, it's kind of simple. What do you have to do to 7 to get 35?
You multiply by 5?
Yeah, exactly. So whatever you do on this side, you do the same thing on the other side. So X is 25, okay? So
Oh, okay.
5:7 is the same thing as 25:35. So here it says, determine the volume of this figure and explain what you did. So again, cut it in half, okay? We're gonna separate it into two different diagrams. So the total volume is gonna be the volume of the rectangular prism on the bottom plus the volume of the cylinder on top. Again, we've done this a few times today. What is the volume of the rectangle on the bottom? How do you find it?
Length times width times height.
Yeah, good. So it's gonna be 12 times. Are we gonna start the formulas on this step? And what is the volume of the cylinder?
Like the area of the two circles.
So volume is base area times the height, yeah? Base area. So the base area is a circle, which is pi r squared, yeah? Times 8, like that. Okay, so because it says explain what you did. So this is what we're doing here. Does that make sense? Base area is a circle times the height. That's will give you the volume every single time. So LWH, again, now it's just plug and chug. 12 times 6.5 times 4 plus 3.14 times the radius is 2.5 squared times 8. And what does that give you on a calculator?
Is it like 15,000 something.
15,000 might be a little bit too big. So we have 12 times 6.5 times 4, yeah? 12 times 6.5 times 4, that is 312 plus, then you have 3.14 times 2.5 squared times 8, and that is 157. Okay? So it's 469. Again, it's asking us for the volumes of meters cubed.
Okay.
So whenever you get like this is called like a composite diagram where you have a mix of different things, you know, like a rectangle, triangle, cylinder. It's called like a composite diagram. You always want to split it up into its individual entities, okay? And then attack it one thing at a time. It's not that bad. Like this one was pretty simple. The house question that we did earlier was a little bit tough, but this one, these ones are pretty straightforward. Yeah. Alrighty, I guess we can call it a day there then.
All right.
All right, and I'll see you when I see you next time.
Okay. Bye.
All right, bye-bye.